Hey everyone, today I'm working on a Schumacher Sports Power SE-2151MA battery charger. This was given to me in non-working condition. I went through it, cleaned some dirt and cobwebs out of it, and found a loose connection on the thermal fuse that I was able to take care of by tightening it up. However, while working on it, I did note that the DC ammeter was no longer working because the plastic that holds the tabs the wires connect to on the meter had gotten very hot and the whole thing deformed. So this caused that needle for the ammeter to bind up. When I tried freeing it up, the needle broke, and since it's nice to have a working meter, the charger otherwise is fairly well serviceable, I searched for a new ammeter online. CenturyTool.net showed the part 53991000120. The horizontal 0 to 100 amp gauge was discontinued. So I found another meter online that I thought I could make work, and I ordered it from Amazon. The one I ended up purchasing was a BAYITE brand, and it was in the neighborhood of $24. I'm going to go over some of the stuff that I did to make it work a little bit better than what I started out with. So, BAYITE. BYT-VAM-036. Oh, in order to get this thing to fit, there's these little notches here. And we've got to get those cut out over here on our piece of plastic. Alright, I marked them, but I marked them on this piece here. Pencil. Alright, so I use a Dremel tool. And I ground the inside of that one out, kind of ugly like. And then the inside of that one right there. So there's a relief for these to snap into. Alright, so our final product then will look something like this. Come on, zoom. So yeah, that should be our unit. And then this will fit inside of here. Like so. No harm, no foul. And then, yeah, so we just got our connectors, our LEDs to figure out. And I think if we can somehow maybe cut this box and still connect those to this shunt here on the meter that broke or melted. I don't know. Alright, so I transferred this piece, which used to be in the old meter assembly. I transferred that to there, so we'll still be able to have our check battery full charge. I cut that with a dike, like a side cutters, and now the LEDs can still go in the back. Alright, so we got her in there and pushed through. And that is nice how nice that snaps in there. It's almost like it was made just for this application. There's a little bit of a gap you can see in the bottom where I ground that. I might have ground too much out, but yeah, hopefully the rest of this isn't too bad to do. Out these two that went on the old meter, and then we've got to figure out our Hall effect sensor. Alright, so this one describes two different ways to connect it. DC 5 to 100 volts, and you can connect the red and yellow wire together. power supply voltage is less than 5 volts or larger than 5 volts, then an external power supply is required. So given that this is between 6 and 12 volts, I believe we can use the 2-wire. So that will be our plan. Power load. And it looks like the load goes on the outside. Alright, so we got it hooked up. We got it routed back to the right side here. Correct side. And then a couple things I'm nervous about is inductance from our transformer. And yeah, that could be causing interference. So maybe tying it in back here on this positive one would be better. I'm not sure. But, oh shoot. Looks like my LED broke. So here is the heat shrink tubing I'm going to try and use, I guess, on this guy. I'm kind of disappointed that that broke. That solder connection wasn't very good, I guess. It's tinned. So we'll repair that and then we'll move on. So I ran my heat shrink tubing down the wire. And it's not melted yet, so, or heated, so it should be able to move back and forth nicely. Just gotta get it out of the way again so that we can solder that nice. We're looking at our battery charger. I got a load on it now. This is my old lawnmower battery. And we are getting a reading of 13.9 volts at 0.4 amps. We are on the 2 amp setting. And I don't know, it just doesn't seem like it's enough amps. I got this in there, can wiggle it around. Seems okay, I don't know. But for some reason, I'm just not getting what I need here. I was hoping it would be reading 2 amps because that's what I thought it was charging the battery at. Alright, so for my connections, I got a rivet in the back panel here. That wire comes around, and that goes to the black wire here. I don't have this soldered and heat shrunk yet, just because I'm playing around with stuff yet. And same for my power wire here. I've got the red and the yellow tied together like it shows in the diagram for this guy. 2-wire. I'm bringing power for this, the red wire, off of this guy down here for now. Yeah, not sure, but I was hoping it would be reading more current than that. And then right now for the power in the back of this unit, I've got it hooked up to, come on, zoom. To this thing. It comes out of there pretty easy though. I don't like how that's set up right now. I don't know if I maybe hot glue it or something. But I would feel better if that was a little more solid, because right now it's, well, I guess it could be worse, but it just sits on these tabs here above it. And I'm sure when it gets the power going through it, it's going to melt. I don't think that's like a electrical insulated, high temperature rated plastic. Alright, so finished product. I got my Hall effect sensor down around one of the inputs. So I'll be reading the current. And this would be the power for the unit. The power with this plugged in now, it reads the battery voltage when you first hook it up before you apply power to the unit, so that's kind of nice. I did put a zip tie around this in the back just to keep that piece of plastic in there, so that'll keep that plastic piece from popping out of there. And yeah, I got my wires all soldered finally, heat shrink on them, and yeah, so it's reading low amps right now, but it's a battery that might have some charge in it. I'm not sure if that's the reason, but I'm going to clean up and put it all back together, and I'll have a nice clean little unit. All right, screws. This one's got to go here. You got one in the back and two on the other side, and that pulls that top cover off. All right, there is our finished product all assembled. Plug it in here, show you what's up. All right, 0.6 amps, 13 volts, and that's on our 2 amp charge. Boost it up, it goes up higher volts, ends up being lower, well, similar amps, I guess. Automatic regular. So yeah, back to 2 amp. This is what the battery's taking right now. If I disconnect it, it drops down to 9.6 and obviously 0 amps. And then hook it back up again and starts charging again. And then if I want to unplug it, that's the readout it gives. It gives you the voltage of the battery and your amperage. And I think when that little light comes on in the corner, that means it's backwards. So it's putting amps back into the charger. But anyway, yeah, that's what we got.